Hi guys, I'm back. This is my fifth video and the fourth session on kinematics. And today's topic is vectors and scalars. I was actually thinking of doing this even before I explained you the resolution of forces, but I somehow thought it's better to give you some explain you something which is more real. Force is very real and you can relate to it, you can visualize it. So I started off with force, but let's take a quick look at vectors and scalars. There won't be much mathematics in this session. It's basically to give you an idea about what these two mean. Now, uh, it's important to understand the difference, and it's very straightforward. Let me explain you this with an example. Let's try to differentiate them: vectors and scalars, right? Vectors and scalars. Now, a scalar quantity is one which has a magnitude. Magnitude meaning a number. Now, if I tell you the speed is 10 kilometers per hour, or I say the quantity is 5 liters, or I say the distance is 2 kilometers. So if you look at all these quantities, whether it is speed, whether it is the measurement of the volume, or it is the distance, all these have a magnitude. This is 10, this is 5, this is 2, followed by units: kilometers per hour, liters here, and kilometers. So if you see there is no mention of direction here. There is no mention of direction in these quantities. Now, in vector, what happens is, in addition to the magnitude, the direction is always mentioned. Now, can you give me some examples? Let's understand this. Let's say, how about what we discussed in the last few classes, force. When we talk of force, we say 5 newtons in north direction, or we can say, we can say, for example, velocity of 10 kilometers per hour in northeast direction. So if you see, it has these for example, force, velocity, or even displacement. For instance, displacement, when I say displacement, I say displacement of 2 meters in the north direction, etc. Now, let me illustrate this with an example, so that will give you a better understanding of how this two how they relate. So let's look at this. Let's look at an example. Okay, let's illustrate this with an example. Let's say this is your house, and this is your school. Okay, This is your school, and this is the road to your school. Okay, let me just draw it. So every day you go, so this is you, so you have to walk up this direction and reach your school. And let's say, let's assume that, okay, you remember the last class I said when you draw freehand drawings, always make sense out of it. So let's now, I was actually going to draw 3 and 4 kilometers here, but if this is 3, this doesn't look like 4, so let's make it look more real, right? So yeah, so let's do it this way. So this is, let's say this is the road, okay, and this is this is your starting point, right? So let's draw your house here, right? And this is you. So this is how you travel. So you take 4 kilometers, you travel to the east, and then after that you turn 90 degrees and you travel 3 kilometers to the north. Now if I ask you, let me change the color here. If I ask you, what is the total distance traveled? What is the total distance traveled by you? What will be your answer? It will be 4 plus 3, right? That is equal to 7 kilometers. 7 kilometers, right? What you have done is you have just added 4 and 3 and your answer is 7 kilometers. So this is your distance, okay? We just added up the quantities, and this 7 kilometers has no mention about any direction. It just says you traveled 7 kilometers. Now if I ask you, what is the displacement? What is the displacement of you from your home? What is the displacement? So displacement basically means how much have you moved in net effect. So this was your starting point and this was your ending point. So displacement is your net change in your positions. So this was your initial position. This was your initial position, and this was your final position. This was your final position. So now if you see, by the application of simple Pythagoras theorem, we know that this distance from here to here will be 5 kilometers. Why it is like that? It is 4 square plus 3 square under root. That is equal to 25 under square. That is equal to 5 kilometers, right? So now if you see, you have a displacement of 5 kilometers at an angle theta. So if you see, we have differentiated distance is a scalar quantity, but displacement is a vector quantity, right? So this is very fundamental. So let's take one more example. Let's say you're driving in a car, okay? You're driving in a car, and we all have a speedometer in the car, okay? We all have a speedometer in the car, and when you drive, if you look up, it may show you the speedometer may be here in this direction, okay? So these are like 10, 20, 30, 40, 50, 60, etc. So whatever the speedometer shows you, let's say it is showing you 40 kilometers per hour. So what is this? What is this? This is nothing but your speed. It just says speed is 40 kilometers per hour. Does it say direction? Does it have a direction? No, it does not have a direction. No direction, right? So speed is therefore a scalar. It's a scalar, okay? Now, but how about velocity? When we say velocity, velocity is nothing but it is your, okay, before we go to velocity, what is the before we go to velocity, what is the from high school we know what is the formula for speed. Speed is equal to distance traveled by time taken, right? Speed is equal to distance traveled by time taken. Now let us go to our school example. Let us say that you traveled 4 plus 3 7 kilometers, and let us say you took 1 hour to drive this, 1 hour to go to your school. So what is your speed? Your speed is, distance traveled is 4 plus 3, that is equal to 7, and let's say the time taken is, let us say you have taken 1 hour, so divided by 1, therefore your speed is 7 kilometers per hour, right? So this is your speed. This is your speed. Now what will be your velocity? What will be your velocity? Your velocity will be equal to, this time velocity will be not distance traveled, it will be net displacement by time taken. Okay, and what will be our net displacement? We can see our net displacement here was how much? It was 5 kilometers. So therefore our, what will be our velocity? Our velocity will be 5 kilometers by, again time taken was again 1 hour only, therefore the answer is 5 kilometers per hour. Therefore we have clearly found out that our speed was 7 kilometers per hour, but our velocity was 5 kilometers per hour. This is a scalar and this is a vector. Why? Because it's a vector, because you have a magnitude, and if you want, you can also find out the direction, like what was the angle it made from your initial starting position. You have a reference, right? So this is the fundamental difference between a scalar and a vector. So you can also refer to your school textbook. It's a very easy concept. Just understand the basic philosophy behind it, and then as we keep moving forward, we'll discuss more. We won't discuss on scalar or vector, but it's good to know what these two quantities are, because, and let me, okay, before I close this, you will also see in your textbooks, I'll give you an example. For example, if you remember our last class, we were using force and we used an arrow on top of it. When you use a variable, f is a variable, right? Variable meaning it can take any value. It is not defined. If I say 5 newtons, it is a constant, right? The basic fundamental. So if I have an arrow on top, this means it represents a vector. But in certain books, you may also find loosely, many people, many authors may not explicitly write, put an arrow. So there are different notations. Certain people write, they may write an arrow. Certain people will write the velocity in bold letters. So a bold letter also represents a vector. So there are different conventions. Some people may write just like this. So there are different notations of it. But essentially, a vector will always be represented with something different, and the best way to do it on paper is by putting an arrow on top of it, right? So, this is the basic difference between a scalar and a vector. I'll see you in the next class. Bye.